Today's lesson is going to be graphing lines and inequalities in slope intercept. It's a long title, and that's because it's really two lessons combined into one. But the first lesson we've already done, so let's review. You know how to do the graphing lines part. I'm also going to teach you what slope-intercept form is. Exactly. So this is slope-intercept form. Slope-intercept form of a line. We're always going to have y equals, and we're going to have the letter m, but that actually represents a number. You're always going to have an x plus, actually I'm going to put the plus in blue. Sometimes it's not going to be plus, sometimes it's going to be minus. But you guys have seen this before. So y equals mx plus b. Everyone say it with me. Y equals mx plus b. And the reason this is called slope-intercept form, the m is the slope of the line, and the b is the y-intercept. And again, this is a kind of a quick review, because you guys have already seen this, and you'll start to recognize it right now. Y equals 3x plus 1 is an example of this. And you guys know how to graph that. We start with the y-intercept. So remember, on a graph, this is our y-axis, and this is our x-axis. I remember that by this y having a long tail going down, making this axis. Okay? So our y-intercept is plus 1. According to slope-intercept form. What that means is when x is 0, y is 1. And we could plug that into a t-chart if we wanted to. You could make a t-chart, a table of values, right, with x's and y's, and you could find a whole bunch of points. But we know a faster way to do this already. We look at that plus 1, and we just make a point right here at y is 1. And then we look at our slope. The slope is how tilted our line is. A slope of 1 is like a 45-degree angle. Right? And the more tilted the line gets, the steeper the slope, the higher this number is. The more gradual the slope, we're going to have a fraction for this number. And you guys have seen that. When we have a whole number here, we actually pretend it's a fraction, right? So instead of 3x, we would usually think of this as 3 over 1. Because that helps us remember what to do. From our y-intercept, we're going to go up 3 and over 1. And we're going to make a second point there. And then usually we're going to do that again. We're going to have our graph by connecting those 3 points. And then remember, all lines go on forever. We're not going to spend forever graphing them, so we draw arrows on each side. So that's review, right? You guys remember how to do this. We've done a lot of practice with this. Just looking at the slope and the intercept. The intercept is where it hits the y-axis. The slope is how far we go up and over. Now, we can also graph inequalities in this same way. So if we're graphing inequalities, we're going to have something like this. Y is greater than 1/2 x minus 2. Let's try that. We're going to start out the same exact way. We're going to look at this y-intercept. On our graph, it tells us how far to go up or down the y-axis. In this case, we go down 2. That's our first point. And we're going to look at our slope. Up 1 over 2. Up 1 over 2. Now, here's where it gets a little bit different. If this were a line, it would say y equals 1/2 x minus 2. We would draw a solid line going through those points. But in this case, does the y equal this? No, it's greater than. So the line is not actually equal to what we have here. It's kind of a way of thinking about it, right? What we have here is saying the y is greater than this line. It's not equal to. And to represent that, we're going to do a dotted line. So not a solid line. What is this kind of similar to? We have our dotted line.
It's sort of a dot line, not really.
I did my best.
No,
Yeah, it's kind of like when we graph these on the number line. Remember, when this was greater than, we used a hollow dot on the number line. When it was equal to, we used a solid dot. So it's going to be sort of like that. When you have the greater than or less than or greater than, you use the hollow dot, less than or equal to, greater than or equal to, solid dot. We're going to use this dotted line for less than or greater than. And we're going to use just a straight line for greater than or equal to or less than or equal to. Okay? So if you have this little line underneath, you make a solid line. This little guy comes and fills all these things in. Right? When you don't have it, when it's not equal to, you make a dotted line. And there's one extra step. This is greater than this line. And so what we're going to do is we're going to shade all the possible area where this is true. In this case, it is going to be up. But what we're usually going to do to figure that out is we're going to find the point 0, 0. 0, 0 is right here. We're either going to have to shade towards 0, 0 or away from 0, 0. Right? There's only two sides of a line. There's this side and this side. We figure that out by taking our original equation, putting in 0 for y, 0 for x, 1/2 times 0. And then we try to see, is this true? So is 0 greater than, what is 1/2 times 0? Anything times 0 is just 0, right?
Yeah.
0 minus 2. What is 0 minus 2?
2. No, negative 2.
Negative 2. Right? 0 minus 2 is negative 2. So is 0 greater than negative 2? Is that true? Yeah, that's true. So do you see how I got that? I put 0 in for y and 0 for x. Now look where 0, 0 is. Since this is true, you're going to shade towards this. Shade on this side of your graph. And so we're going to shade this entire.
Oh, you sort of taught us this, Gary.
Gary showed you a little bit of this?
Yeah, the shading.
So we're going to shade this whole side. Yeah, you can, you can shade however you'd like to. Sometimes it can be fun to use different colors to shade. Things like that. So there's a couple things that I want to point out. And these should go into your notes. For greater than or less than, use a dotted line. So these are our rules for graphing inequalities. Greater than or less than, use a dotted line. Greater than or equal to, or less than or equal to, use a solid line. And then shade one side either toward or away from the point 0, 0. So when I write a point like this, you guys remember what that means on the coordinate plane? 0, 0. That would be right here. Now I want to show you why we do this. You could choose any point in this shaded area, and it will make that equation true. Any point. So like there's a point right here, right? That point is like 3, 10. Right there, right? Does everyone see that point? That's a point. There's infinite points over here, but that's one of them. And if I take that point, 3, 10, and I put the 3 in for x and the 10 in for y, so I have 10 is greater than 1/2 of 3 minus 2. This is going to be true. 10 is greater than 3/2, right? Minus 2. 3/2 minus another, instead of 2, we'll check 4/2. 10 is greater than negative 1/2. That's true. But if I pick any point over here, so let's do like this point. 10, negative 2. This point here. So I'm going to plug that in for y is greater than 1/2 x minus 2. If I plug that point in, negative 2 greater than 1/2 times 10 minus 2. This is not going to be true. Negative 2 is not going to be greater than 5 minus 2. Negative 2 is not greater than 3. This is not true because I chose a point that is not in my shaded area. Okay? So that's why we shade up here. It's because every point that I've shaded makes this inequality true. Everything that I've shaded. I could pick a point way up here, right? And it would be true in this. But everything over here is not true. Any point that I pick down here is going to make a statement that's not true. Like negative 2 is greater than 3. That's crazy. Totally not true. So the shading represents every value that makes this line or this equation true. Okay? Let's do 3 examples. And there is sort of an exception to this, but we're not going to go into that today. but I'm curious if you guys have seen it. So example 1. Y is less than or equal to 2/3 x plus 1. Alright, how do we start?
Hold on.
Start with the 1. We go up 1, make it up. Where's our next point on this line?
Up 2 and then over 3.
Up 2 over 3, we make another point. Let's do that again. And our point is about there. Okay, solid line or dotted line? Why is it a solid line?
Because I think the line under shows that it's solid.
That makes it solid. Okay, my points are a little off. You can see we'll have to kind of do our best here. Okay. Which side of this do I shade on? We don't know yet.
Yeah, we don't know.
What we want to know is, are we going to shade towards 0, 0 or away from 0, 0? So in this case, if 0 is y, is 0 less than, this is going to be 0 plus 1. Is 0 less than 0 plus 1? 0 is less than or equal to 1. Is that true? 0 is less than 1, right? So we shade towards 0, 0 because this is true. This is true. So we shade towards that point. Okay, second example.
And that's the answer?
That's it. Your answer is a graph.
Oh, nice.
Okay.
That's so fun.
Y is less than okay. Start with the -5 by going down 5 on the y-axis. Then going up 1 over 2. Up 1 over 2. Solid line or dotted line?
Dotted.
Dotted.
There's no line under it.
There's no line under it. It's not equal to.
Shading part.
The shading part is the new part, right? That's the tricky part.
Yeah.
Okay. So let's look at this. Here's 0, 0. Let's plug that in and see if it's true. So 0 is less than 0, or 1/2 of 0, but anything times 0 is going to be 0, right? So 0 is less than 0 minus 5. Is 0 less than -5?
It's more.
No. So that's not true. Which means we want to shade away from this point. This point is not true. So we're going to shade on the other side.
Oh, so if it's a negative number, then you're going down, or if it's a positive number, then you're shading up?
No, if it's true, you're shading towards 0, 0.
Yeah.
If it's not true, you're shading away from 0.
And do you only plug in 0?
You always plug in 0, 0. It's just the easy, I mean, you could plug in whatever you wanted. It's just really easy to plug in zeros, right?
Yeah, that makes a lot
Because 0 is just a really easy number to use. 0 times something is 0, and 0 minus something is just, you know, negative something. And it's just easier to plug in 0, 0. You could have plugged in like 100 and negative 1,000 if you wanted to, right?
Yeah.
And then figured out if you shade towards that or away from that, but it's just really hard.
Yeah.
It'd be like, okay, let's see, 100 negative 1,000. So is negative 1,000 less than 500 minus 5? I'm not totally sure.
That's easy. Could you just
But 0 is definitely not less than negative 5. That's
yeah.
That's fairly easy to see. Okay, one more example.
Okay.
Y greater than or equal to negative. All right, where do we start? Start with that plus 7 by going up the y-axis 7 spots,
Then
making a dot.
wait, down 2 and
Down 2 over 3.
wait to that side? But it's a negative fraction.
Yeah, that's why we go down, right?
Oh.
We always go to the right,
But doesn't
but
it
we
also
just
count?
change if we go up or down.
Oh, it's on the 2. Okay, I put it on the full fraction.
It doesn't matter. It could be out here. This is the same thing. Yeah. And then we're going to just go down to one more. 2 over 3 one more time.
It's gonna be solid.
And it's going to be a solid line.
And
And
0,
again, my points are a little off here. But
and 0.
you'll forgive me, right? For my points not being perfect. Okay, now we've got to figure out, is this point right here, 0, 0, true in this inequality? Is 0 greater than or equal to 0 plus 7? No, no way! 7 is definitely bigger than 0. So this is not true. So we do not want to shade towards this.
We shade up.
So we shade on the other side. This is going to be your homework.
I have homework, which I'm guessing we will.
All right. Cool. All right.
Well,
Questions about that?